We are working on the Connect 4 project from the YByte Python curriculum available at www.ybyte.in. In the previous video, we created a list of lists. Uh, we saw that it's important for us to create it in a way so that we can access each of these items individually and change their values without impacting everything else. Uh, en route, we saw also an incorrect way of doing it, which was basically to create one row and appending it over and over again. And we saw that when we did this, basically the matrix or the, let's say, the list of lists was not accessible, let's say, individually. For example, here I'm saying board 03 is 2, and I noticed that in fact I just wanted to change the, let's say, the fourth item of the first row, which is, let's say, this item, but I realized that everything here has changed. In fact, the third item on all the rows of the board has become 2. That is a problem. Now, in this video, we will get a little bit deeper into this, what exactly is going on here. In fact, the reason for this is what is called shallow copying. What we are doing here is inadvertently a shallow copy, but we'll try to understand this with many more examples so that the whole process becomes very clear. This is quite important to understand about Python and also somewhat confusing, especially for programmers who have come from another language or even for, let's say, completely new programmers. So, this is a very important topic in general. Let's see what goes on. So let's say I want to create, so I have this board over here which I've created, but let's say I want to override this and I say, okay, look, board is, an empty list. I just create, let's say, a row which is, say, for example, 0, times, say, 7, doesn't really matter. And then I just go and say for, say, in range, maybe say 6, so I want to do 6 rows and 7 columns, let's say. If I were to do, let's say, this board dot append row, now we know this is not the right method, but at the face of it, if I were to say display board, it looks all fine. Board is in fact indeed the way I would kind of like it to be. But the problem is, like I said, if I were to go and do board 2, say 2 is equal to 2, let's just say I will see that in fact all the second items in every row has got changed. So the question is, what has gone wrong? Well, the answer to that question lies in an operator which I'm going to introduce now. It's called the ID operator. So I can look at the ID of an object. Let's look at the ID of, let's say, board 0. It's a large number, doesn't really matter. The exact value doesn't matter. But you notice something interesting. If I look at ID of board 1, it is exactly the same number. In fact, the ID of each of these is in fact exactly the same. Now, what does this mean? You can think of ID as an address in the memory where this, let's say, list is being stored. Now, the exact value of this doesn't matter, but the fact that they are all same implies that in fact in the memory they are pointing to the exact same location. What does that mean? When I go and change one of them, in fact, they are all pointing to the same location, and as a result, all of them change. Now, this is precisely what is called shallow copying. Now, this has to do with how Python stores lists internally and how it handles all these, let's say, references. In the method that we have chosen, in fact, Python interpreter is just copying the reference. Hence, all the rows are in fact still pointing to the same list as we saw from the ID, which is why when we change one, in fact, all get changed. Now, like I said, this is called shallow copying. Let me try to illustrate this with a diagram here. Let's say I have a list called A. Remember, list is all basically a collection of variables, and every variable is a box with a label. That box is basically a memory location. So my A is pointing to a certain memory location. Now, when I do an operation of the sort, let's say B is equal to A. Now, in my mind, I'm copying B to A, but what the Python interpreter is doing is that it's just creating a new variable pointing to the same memory location, which is why if I go and change B, in fact, A is also changing. Let's see this with an example. Let's say I have, a list called, let's say 1, 2, 3, 4. If I were to do this, well, if I were to do, let's say, like, so let's look at the ID of A. That is, again, some large number, but doesn't matter. I go and do B is equal to A. In my mind, I've created a new list, but all that has happened really internally is that if I look at the ID of B, it's in fact pointing to the exact same location. Now, if I were to go and do, let's say, b dot append a, so b dot append, let's say 10. Now, in my mind, b has become 1, 2, 3, 4, 10. What I need to be aware of is because I done a shallow copy, In fact, even A has become 1, 2, 3, 4, 10. Now, this is very, takes people by surprise when they are not careful about it. But really, that's what's going on, is that this statement creates a shallow copy. We can see this further. If I were to go and remove, let's say, some item from B, let's say I go and remove 2. So B is 1, 3, 4, 10. Amazingly, even A is that. No surprise really, because they are really both pointing to the same exact object. Same thing happens in sets. Let's say instead of list, I had a set 1, 2, 3, 4. And obviously the type of A is now a set because I had a curly bracket there. If I were to do B is equal to A, the ID of B, ID of A is this, ID of B is in fact the same. And we can find this out also by using the is operator. So if B is equal to A, that is actually true. Now, what this means is that if I were to go and remove, let's say, something from B, so I remove 2, for instance. Now, notice A also doesn't have 2 because they were both pointing to the same object, as we see from the is operator, or let's say from the ID. Same exact thing applies to dictionaries. Let's say I had a dictionary which is one, let's say 2 keys, 1 and say 2, and the value is, let's say, TWO. Uh, So that's A. If I were to do B is equal to A, once again, ID of B is some number. ID of A is exactly the same. So which means they are really pointing to the same thing. Let's say I go and modify B and I go and add a third key, let's say is say 3. The value is say 3. If I look at A, in fact, magically A has also got changed. But really there's no magic because we had created a shallow copy. So basically, that's what is going on in the so-called incorrect method. We are inadvertently creating shallow copies of the same list, and hence we can't access every list individually. And that's obviously a problem. But then the question that comes up is, well, how do I solve this problem? Well, we already saw the answer. We need to do basically some kind of an explicit copy. So for example, here I'm explicitly creating that, every row for basically I'm explicitly creating every row for that many rows. Or it was even more clear, for example, when we did these for loops, we are creating every row explicitly as part of the loop. That's one way. The other way would be to use, let's say, what is called a deep copy method. So I can go and say, well, import copy, and I can go and say, well, C is, let's say, copy dot say deep copy say A. Now, when I look at ID of C, that is different from ID of A. So ID of A is whatever it is, and I can also see A is C is false, whereas A is B is in fact true. Which what that means is that C looks like this, but if I go and change, let's say I go and add say one more key to the dictionary, C is say 4. You notice A is still whatever it was, and C is now this. That's because, again, like I said, the IDs here are different, and hence now A and C are pointing to two different memory locations, which is what helps us. So to summarize, the right way to make a two-dimensional list is to avoid shallow copying. The way I can do that, we have seen explicitly copy all the values using a for loop or a comparison. This works quite well. You can also use slicing for lists. So if you create a slice, it's a new explicit copy. Or you can use, like I said, the deep copy module, a deep copy from, let's say, the copy module. I hope this has been clear. This is kind of very interesting and often somewhat confusing. But if we are clear with the concepts, it doesn't confuse anymore. Before wrapping up, let me just take you back to some other projects where we have used this without talking too much about it. Now let's go back to our metro map project. Remember, the metro map has two lines. I got to figure out, um, which line am I looking at for the start and stop. In fact, I've mentioned here in the notes that we are creating a shallow copy, but that is okay for us. Notice this statement is in fact creating shallow copy. So I am creating a shallow copy of the the STNSL in start line, stop line, but that is okay. And what I do next is to use the is operator, which is basically saying that, look, this and this are both pointing to the same location in the memory, and hence this is the same line. So this shallow copy was perfectly fine. It did not, let's say, bother us because we were not changing these things after they had been copied. Another example came in our Sports Heroes project where we wanted to look at the more than once winners. The way we did it was, creating an empty set and then explicitly or adding all items from, let's say, winner set into the empty of winner set. Now, if on the other hand, we had done empty of winner set is equal to winner set, we would end up in a problem here because when I remove items from the empty of winner set, unknowingly winner set will also get changed because I would have ended up creating a shallow copy. So here I have intentionally created a deep copy without talking about it, but I did give you a food for thought. We did not do this. Why did we not do this? Well, the reason we did not do this instead of copying one by one is because this would have created a shallow copy and that would have resulted in a problem when I ran the for loop. Again, think through this. Very, very interesting and very explicit when we, let's say, see this in action. So coming back to the project at hand, remember we are doing this list comprehension to sort of create the list of lists. This is perfectly fine because you realize that the rows are not shallow copies of each other. In fact, we can see this in action right now. So if I were to do this, if I were to look at my board, it is what it is. But the important point is if I were to look at the ID of, let's say, board, say 0, that is something. An ID of board of 1 is something totally different. So they are pointing to different objects in memory, and hence I am able to access the items exactly as I wish to. Very, very important point. I hope this is clear. Do think about it, and I'm happy to discuss in case you have any questions. Um, but as you see very clearly, building activities around concepts makes them that much more vivid, that much more easy to understand. And that is exactly what we're doing at YByte. Look at our website, www.ybyte.in, because we learn Python programming through such fun activities. Take care. Thank you so much. Bye bye.